Hello and welcome to our today's lesson, and today we are going to analyze a simple truss using the method of sections. Since we have been dealing with the methods of joints, method of section is another way of determining the forces in the members of a truss. Now, this method is majorly used when a few members of a truss are to be, that is, the forces in a few members of a truss are to be determined, and it is a very quick method as it does not involve the solution of other joints of the truss. Now, in this method, a section line is passed through the members in which the forces are to be determined. So we have to pass a section line through the members in which the forces are to be determined. The section line should be drawn in such a way that it does not cut more than 3 members in which the forces are unknown. The part of the truss on any one side of the section line is treated as a free body in equilibrium under the action of external forces on that part, and the forces in the members cut by the section line. And therefore, the unknown forces in the members are then determined by using equations of equilibrium. Now, on our board here, we have a truss that is loaded with 3 external loads. On end A, the truss is hinged, and on end B, the truss is supported on rollers. The question is, using the method of sections, determine the forces in the members CE as well as the member FG. And that's why we have seen that this method is usually used when the forces in a few members of a truss are to be determined. A very quick method. Now, we are going to begin with determining or calculating the reactions at A as well as the reaction at B. Therefore, we are going to write here reactions, calculations, reactions, calculations. And for us to get the reactions at A as well as the reactions at B, we are going to take moments. Therefore, taking moments about B, about and B, taking moments about B, we are going to have the following. Therefore, we get, so we are going to have RA multiplied by the distance from A all the way to B, which is 6 meters. That is a clockwise moment, is equals to the following anti-clockwise moments. Remember, the sum of clockwise moments must be equal to the sum of anti-clockwise moments, and therefore this is a clockwise moment being equal to the following anti-clockwise moments, and one of the anti-clockwise moments will be 7.5 times the distance from its point of action up to B, which will be 1.5 meters. Since that is 2 meters minus 0.5, that is 1.5, and therefore we are going to have 7.5 multiplied by 1.5 meters plus we have 5 kilonewtons. When you drop this line, this point up to the member FG, we are going to have 1 meter, because this is 2 meters being cut into 2 equal parts, and therefore this is going to be 5 multiplied by 3. Therefore, that is 5 times 3, okay? Plus 2.5 multiplied by 0.5 plus 4. That is 4.5. Therefore, plus 2.5 multiplied by a span of 4.5 meters. Therefore, this is going to be RA multiplied by 6 being equal to 37.5 kilonewtons. That's 7.5 kilonewtons. That is the sum of all these multiplications. So to get the value of RA, we are going to divide both sides by 6. And when you divide that 7.5 divided by 6, that is going to be 6.25 kilonewtons. Therefore, the reaction at A is going to be 6.25 kilonewtons. Now, to get the reaction at B, remember the sum of all the upward forces must be equal to the sum of all the downward acting forces. And therefore, the sum of the upward forces, we have RA plus RB. RA plus RB, those are upward acting forces, will be equal to the downward acting forces, or the vertical forces. We have 2.5 plus 5 kilonewtons plus 7.5 kilonewtons. 7.5 kilonewtons. And this is going to lead us to, we have the value of RA, which is 6.25. Therefore, 6.25 plus RB is equal to, when you add 2.5 plus 5 plus 7.5, that's going to give you 15 kilonewtons. Therefore, RB, that is 6.525 plus RB will be equal to 15 kilonewtons. Now, to get the value of RB, we are going to have RB will be equal to 15 minus 6.25 kilonewtons, and therefore the reaction at B, that is RB, is going to be 8.75 kilonewtons. 8.75 kilonewtons. And therefore, ladies and gentlemen, we now have the reactions at A as well as the reaction at B. So we are going to come here at A and write our reaction of 6.25 kilonewtons. Then come here at B and write our reaction, which is 8.75 kilonewtons. Good. After determining the values of the reactions at A as well as the reaction at B, the next thing will be determining the sizes of various members. And in this case, we are going to begin with determining the distance from E to H. I've named this part H. And this is, can call it the perpendicular distance of triangle EFG. And in this case, I'm going to produce this triangle here. And we are going to have the following. This is what we have. This is what we got. This is what we got. This is what we have. Yep. Then have that. So this is a point E. This is point H. Let me call this point J. Yep, point J. This is point H. That is point J. And we got an angle of 30 degrees here. The distance from H to B, that is B, is going to be, we have the distance from J to G, which is the same as H to G, that is 1 meter plus 2 meters. So that is 3 meters. So we have 3 meters. Now, treating this triangle as a right-angled triangle, we have the adjacent and we need the value of the hypotenuse. Therefore, we can say that the value of the distance E to H is going to be given by the adjacent multiplied by the tangent of angle 30 degrees, because tangent is given by the relation between the ratio of opposite to the adjacent, and this is going to give us 1.732 meters. 1.732 meters. Therefore, the distance from E to H is 1.732 meters. And this gives us the distance from E to J. Remember, this section here is 0.5 meters. Distance from H to J is 0.5 meters, and therefore the distance from E to J will be 1.732 meters minus 0.5 meters, and that's going to give us 1.23 meters. 1.232 meters, approximately 1.23 meters. Therefore, we got this perpendicular distance, which is now 1.23 meters. Now, after getting the length of E to J, the next member we are going to determine its size is member AF. Therefore, length of member A to F. So we have this triangle or these figures here. Then this is slanting like that, and then we have an imaginary horizontal distance there like that. So this is an angle of 30 degrees. This is joint A, this is joint C, this is joint F. We have an angle of 90 degrees at that point. Now, the distance from A to F horizontally is 2 meters. That's the distance of A to F. That's 2 meters. The distance from, if we drop a perpendicular height, that is a vertical, perfectly vertical line there. The distance from that point to F is 0.5 meters. Now, we are going to begin with calculating the distance A to F, the distance A to F. And in this case, for us to get the distance A to F, so the length of member AF, we have the following. We have 2 meters here. We have this height, 0.5 meters, being 0.5 meters, this one is equal to that distance. And therefore, since this is 90 degrees, we are going to use Pythagoras theorem, which states that A squared plus B squared is equal to C squared. We need the value of C, and therefore the value of C will be given by A squared, which is the value of A is 2, and therefore 2 squared, plus B, which is 0.5, we square it. We get the square root of that. That will give us the value of C. And in this case, C is the distance from A to F, which is acting as a hypotenuse of this triangle that we got here. So, the size of the hypotenuse is going to be 2.06 meters. 2.06 meters when you get the square root of this. So this will be 4 plus 0.25, which is 4.25. Therefore, square root of 4.25 is 2.06 meters. From there, we need the value or the size of member CF, member C to F, and therefore can say member CF. Awesome. Now, to get the length of member CF, first of all, we need to determine the value of this angle, angle CAF, angle CAF. And for us to get the value of angle CAF, we are going to use triangle AF, let me call that part K, and we are going to use triangle AFK. Therefore, in triangle AFK, we have the opposite, which is 0.5, and we have the adjacent, which is 2 meters. So we are going to get the value of this angle by saying this tan beta will be given by the opposite divided by the adjacent. So the tangent of this angle, angle FAK, and therefore tan beta will be given by the opposite is 0.5 meters. Therefore, we got 0.5 meters divided by the adjacent, which is 2 meters. 0.5 divided by 2. This is going to give us tangent beta being equal to 0.25. Therefore, 0.5 divided by divide by 2, that's 0.25, and therefore angle FAK will be given by the tan inverse of 0.25, which in this case the tan inverse of 0.25 is 14.04 degrees. Therefore, the value of angle FAK is equals 14.04 degrees. Therefore, that is the value of this angle here, FAK. Now, to get the value of angle CAF, we are going to take 30 degrees, the value of the whole angle, minus 14.04. Therefore, we got 30 degrees minus 14.04 degrees, and that's going to give us 15.96 degrees. 15.96 degrees. Awesome. So, therefore, we have the value of this angle, which is 15.96 degrees, and therefore we can now easily get the length of member CF, and we have said that this is the hypotenuse, that is AF will be the hypotenuse of triangle CAF, and this is the opposite, and therefore that is sine. So the length of CF, that is the opposite, will be given by the hypotenuse, which is 2.06 multiplied by the sine of angle 15.96 degrees, and in that case that will be equal to, therefore CF is equal to 0.57 meters, and therefore the length of CF is 0.57 meters. From there, we determine the length of member AC. Therefore, length of the member AC. In this case, AC is equivalent to CE. Those two lengths are equal. Alright, for us to get the length of member AC, we are going to use this triangle. A, E, we call this H. Remember, we have H there. A, E, H. So that is a right angle triangle. So we have we want the length of A to E, and we have A to H, which is 3 meters. That is 1 plus 2 meters. So we have the adjacent and we need the hypotenuse, and therefore we can say this. The length of member AC. Remember, the cos theta is given by adjacent divided by the hypotenuse. Therefore, cos 30 degrees will be given by the adjacent, which is 3 meters, divided by the hypotenuse. And in this case, the hypotenuse is the length of A to E. Therefore, the length of AE is going to be 3 divided by cos 30 degrees. So the value of the length A to E is 3.46 meters. 46 meters. Now, as we have said that A to C will be given by half of AE. Therefore, AC is equals half of AE. And AE is 3.46 meters. Therefore, 3.46 meters, we divide it by 2, that is 1.73 meters. 1.73 meters. So, ladies and gentlemen, we now have the length of the various members that we require. Good. Now, after determining the sizes of various members, we are now going to consider the equilibrium of the left section. That is II. Left section of this truss, that is section 1-1. We have section 1-1. You can also call it section II. So we have the joint A with a reaction of 6.25 meters. Then we have member AC 1.73 meters. At C, we have an external vertical load of 2.5 kilonewtons. And then we have a member C2E. So we have a force headed towards that direction. Then we have member A to F, which is 2.06 meters. And then we have a force headed towards that direction of joint E. Then from F to G, we have another load headed towards that direction of G. Now, we are going to begin with taking moments of forces, taking moments of forces about E, taking moments of forces about joint E. We are going to get the following, and in this case, when we take moments about joint E, we are going to get the force acting on member FG. How in this case? So when we take moments about E, we are going to have F, that is the force FG, multiplied by 1.23 meters will be, that is plus. So FFG times 1.23 plus 2.5 multiplied by 1.5 is equal to 6.25 multiplied by 3. So in this case, we have the force FFG, that is the force acting on this member FG, multiplied by the distance. Remember, you are taking moments about E. Therefore, the force acting on this member FG times the distance from J to E. Therefore, FFG times 1.23. Plus, we have a force of 2.5 kilonewtons multiplied by the distance from the point of action of 2.5 kilonewtons to the vertical, that is the point of action of the 5 kilonewtons on the member FG, which in this case would be 0.5 plus 1, which is 1.5. Therefore, we have 2.5 kilonewtons acting at this point times the horizontal distance from that point of action of the 2.5 kilonewtons load to the point of action of the 5 kilonewtons load on member E, which in this case is 1.5 meters. That the sum of those two loads will be equal to 6.25 kilonewtons, which is the reaction at A, times the distance from A all the way to the point of action of the 5 kilonewtons load at E, which in this case is this point at H, which is 2 plus the distance from F to J, which is 1 meters. Therefore, 6.25 times 3. This is a clockwise moment. Therefore, these two are anti-clockwise moments, which are equal to this clockwise moment. And therefore, we are going to have the following: FFG times 1.23 being equal to 6.25 times 3 is 18.75. Therefore, 18.75 minus, when you take 2.5 times 1.5, which is 3.75, the other side of the equal sign is going to be minus. Therefore, minus 3.75. And to get the value of FFG, we are going to divide both sides by 1.23. So 18.75 minus 3.75, that is 15. Therefore, 15 divided by 1.23, that's going to be 12.195. Therefore, the force on member FG is going to be 12.195 kilonewtons. 195 kilonewtons. And in this case, that force being positive is going to be a tensile force. So that is a tensile force. So now we have the value of the value of the force on the member FG, which we have been asked in our question. Good. The next force we are going to determine is the force on the member CE. And in this case, we are going to take moments about F. Moments about F. Therefore, taking moments about F, taking moments about F, we are going to get the following. We get taking moments about F, we are going to have FCE multiplied by 0.57 plus 6.25 times 2 is equals to 2.5 times 0.5. Therefore, FCE, that is the force on member CE, multiplied by the distance from C to F. Remember, we are taking moments about F. So, CE multiplied by the distance from C to F, which is 0.57, plus the reaction at A, which is 6.25, times the distance from A to F, which in this case is 2 meters. 2 meters is equals to this load of 2.5 kilonewtons times the distance from its point of action to F, which is 0.5 meters. Therefore, the sum of that is the sum of clockwise moments. Clockwise moment, we have 6.25 times 2 plus FCE plus 0.57. The anti-clockwise moment that we have is 2.5 kilonewtons times 0.5 meters. Therefore, FCE will be given by, so FCE times 0.57 plus 6.25 times 2, that is 12.5, is equal to 2.5 times 0.5, that is 1.25. So this is going to be FCE times 0.57 being equal to 1.25 minus 12.5 kilonewtons. And therefore, this is going to be FCE times 0.57 being equal to 1.25 minus 12.5, that will be 11.25, and in this case negative, so negative 11.25. To get the value of FCE, we divide both sides by 0.57. And therefore, the value of the force on member CE is going to be negative 19.75 kilonewtons. Therefore, 11.25 divided by 0.57 is negative 19.74. Sorry, negative 19.74. Now, that force being negative, it is going to be a compressive force. Therefore, we are going to ignore the negative sign and replace it with compressive. Therefore, that force on that member is a compressive force. And therefore, ladies and gentlemen, we have the values of the forces on member CE as well as member FG. So, ladies and gentlemen, thank you very much for watching our video. Please remember to subscribe as well as to hit the notification bell. Let's meet in yet another lesson. Thank you.